Hi, I'm Caitlin Rivera and I'm in Block B. Today I'm going to prove the theorem, the opposite sides of a parallelogram are congruent. First I'm going to draw a parallelogram. I'm going to label the vertices A, B, C, and D. To make sure the lines are congruent, I'm going to show you. Now I'm going to draw the transversal line that bisects diagonally. There you see that there is two congruent triangles. I'm going to color each one so it is easier to see. In the picture, line segment AB is parallel to line segment DC. And line segment AD is parallel to BC. That we know by the definition of a parallelogram, which states a quadrilateral where opposite sides are parallel. With the alternate interior angles theorem, we know that angle ABD is congruent to angle CDB. We also know that angle ADB is congruent to CBD using the alternate interior angles theorem, which states if two parallel lines are cut by transversal, then alternate interior angles are congruent. We know that line segment DB is congruent to itself using the reflexive property of congruence, which states that DB, which DB is always going to be congruent to itself, which that's what the reflexive property of congruence is that any angle is always congruent to itself. With that being said, we know that that's created angle side angle, which DB is angles side, and angle CDB is the angle's first side, and angle ADB is the last side or angle. Which brings it down to what we're trying to prove. That angle, or that triangle BAD is congruent to DCB. The two triangles are the same. That turns into CPCTC, which is corresponding parts of a congruent triangles are congruent. With that being said, the line segment AB is congruent to line segment DC. Also, line segment AD is parallel to BC. That's how you know you have proved your parallelogram theorem.